Hi, this is Russ. I'm with Devoted Golfer TV. We're at the 2020 PGA Merchandise Show. I'm with Mark Timms and Kim Braley. And these two guys have been friends for a long time. And I'm about to hear a story. You know how I love to hear old tour stories, right? And I'm about to hear a story about how the two of them got together.
Well, obviously, I went to school and played golf a little bit, and I knew a guy, Jim Laubenschlager, at a driving range, whatever, and he was good friends with Kim. So I actually went to Kim originally in 1992, I believe it was, when I first started my store in Connecticut, to be one of the, actually was the first group that ever did a frequency matching seminar and licensing type of deal. So we became good friends back in 1992, and now it's almost 30 years later than that, but we've all been in the industry forever, and Kim's obviously been a good friend, and I built frequency machines for them at some point in time. Obviously, I'm in the club fitting world. He's in the shaft fitting world. But those are closely related, right? So we both work together on the same things. And now, 25, 30 years later, Kim works out of our store and uses our R&D and some other stuff to help develop shafts for club fitters, right? So that's the business we're in. We're in club fitting business. And Kim has done a great job, dedicating his life to helping club fitters do a better job fitting and giving a wide variety of shafts that fit a bunch of people. So he's gone from steel to graphite, hybrids, and now woods. And I've been happy to be friends with him for a long time and play golf and work on how we can make the club fitting business better.
So what do you think of the new wood shaft?
I think it's great. We've done some testing on it and stuff. We've got to do a little more testing to see which one people it fit. But so far, the initial testing from the tour players, Kim's telling me, and the ones in our store, has been fantastic. So it's definitely the evolution of the steel iron shafts, which he dominated for a while, to the hybrids, which made some sense, and now into the woods.
Yeah. So I saw the profile as like the same as the hybrid.
Yeah.
Which was the same as out of your other stuff, a very, very smooth, even, steady release. And it hasn't changed.
Fortunately, the same formulas and my philosophy, when we first started with the woods, I wasn't 100% sure that it was going to work as well as it did with steel. But physics doesn't really change. That's one thing that's nice. The laws of physics don't change. Mm-hmm. And we were able to incorporate the same type formula in this shaft, and how we got to the driver shaft was, I like to take things in kind of a progressive order, and mm-hmm. not, kind of stay in our lane, and maybe it'll take a little bit more time to get there, but try to do it as well as possible. So the first shaft that we produced in graphite was a hybrid. Obviously we're in the iron business. Personally, I've gotten tired of looking at, it used to be 2-through pitching wedge was the set. And then it became 3-through pitching wedge. And then it became 4-through pitching wedge. And we're losing shafts. So I took the opportunity to go ahead and try to get some of those shafts back by producing a hybrid. And the hybrid was incredibly successful. The first week on the PGA Tour, we didn't get the shafts until Tuesday. It was the second FedEx event, so it was a limited field, and also people don't change during FedEx. People are pretty, that's the time of year that they need to concentrate and not be fiddling with their clubs. But that afternoon, we converted. And we were just looking for feedback. We weren't trying to, you're always trying to get the guys to play your stuff, but that wasn't really what we were trying to do at that time. We were just trying to get some feedback. But like I said, we had 5 players switch during the FedEx, which is, again, it's not a time of year that somebody's switching golf shafts. In Europe, our rep over there, Paul Steels, actually converted 17 people the first week he had the shaft available. So anyway, okay, so we know that the hybrid was working well, and I knew that I could use the same EIs, mm-hmm. Or very similar, and one of the things that I do with all the products that KBS makes is we have a progression in stiffness throughout the length of the shaft that's equal. And so, in other words, if you'd measure a 2-inch section or whatever that section may happen to be, the next 2-inch section is going to be the exact amount of reduction in stiffness as the 2 inches above it, as the 2 inches above it, as the 2 inches above it. So the whole thing is once this thing is loaded, you don't want anything to get in the way. You want this thing to load and unload as efficiently as possible. And by doing it that way, we found that it makes the shaft, number one, it makes the shaft feel really good. I mean, I've never had anybody tell me a KBS shaft didn't feel good. Now, I mean, I'm not saying that it may have not fit a person, but it does make it really, really feel good. It allows for a player to play slightly stiffer shaft than they ordinarily would, which actually increases the amount of energy that's transferred, unlike what we were, there's so many things that over the years, has been passed down, and after a while, something gets passed down for a while and becomes almost a fact. But the thing about fitting a person in the most flexible shaft that they can control is not something that I particularly prescribe to. I feel that you should play the stiffer shaft that you can load. It increases the transfer of energy. There's more energy to be transferred, and also one of the really beneficial things, especially in irons, is this dispersion. And anyway, so we developed the hybrid using the same philosophy that we do on the irons. We went in and then did graphite irons, which I don't, like, I'm not bragging. This is, it's real. So we immediately got Kuchar. We immediately we were successful right out of the box. The PGA, we had 3 times more graphite shafts in play than anybody else. So anyway, so the irons were successful, and now we got to the wood shafts. And this shaft, more so than anything that I've ever done, including the hybrid, it's exceeded any expectations that I had, or that we had as a team. And it's been incredibly exciting. Driver shafts are fun. And like I said, I'm just really, really excited about what's going to happen. We don't know what the next product's going to be because we don't have enough data yet. We haven't had enough exposure to be really, to understand what it is that we need to work on next as far as the driver is concerned. But this shaft will be the backbone of our entire line. This shaft will be similar to the KBS Tour, which is the, every one of the steel shafts in the KBS line was based off of the KBS Tour as far as the benchmark. We found that there were players that needed lower ball flight, less spin, so we went to the next shaft that we developed was a shaft that had a lower ball flight and less spin, which was the C-taper, and then other variations. But really what I'm getting at is I don't know what we're going to do with this shaft next, because I don't know. I don't know what it is that we need to make it better, or if there's something that we're missing. But we'll find that out, and that will be the evolution of this product.
I helped him a bunch with the development of the graphite iron shafts, and we developed all these graphite iron shafts, and they were great. They worked well. And over time, with our fitters and getting data and stuff back, we said, okay, that's great, but we need a higher launching one. Mm-hmm. So we ended up with the Max, right? Because our fitters said, that's great, we need one higher launching. That'll probably happen with the driver at some point, whether it's higher launching or lower launching, we don't know. But as we get more data over time with more fittings, we'll figure it out. And the nice thing that Kim's done, though, is he's developed a shaft matrix, basically, that helps club fitters. So, like you said, started with KBS, great shaft, felt good, went a little high, so C-taper went lower, super light stuff went higher, and you kind of fill in around that basis. And that's the same thing you're doing with the driver shafts. This is your platform here. Where you go from there, I don't know, but the whole system you can get the steel irons or the graphite irons, you go to hybrids that match that, and then drivers that match that. But the whole thing with all the club fitting we do is not just to fit a driver shaft or an iron shaft, it's to fit a whole set that works together. And that's what, kind of my philosophy and Kim's philosophy as we've worked together for 25 years or whatever. It's how do you make the customer play better overall? So it's blending all those things and having a variety of different resources, higher launch, lower launch, for all the different players, and getting a matrix that works for everybody. Whether it's a 50-gram hybrid shaft or iron shaft to a 130-gram steel shaft, which is super stiff for, the tour players of the world. But to have the range of things and have everything kind of blend together, and that's, I think, one of the things that a lot of club fitters miss is, you can get this part right or that part right, but there's a whole set that needs to match. Now, that means 50-gram driver shafts, 60-gram fairway shafts, 75-gram hybrid shafts, and maybe 100-gram steel shafts in irons and 120 grams in wedges. But the whole set needs to work as a group. And they've been very cognizant of what goes on because they're actually sitting next to us watching all these fittings go on how that whole system works together.
And so, in your experience so far with the new driver shaft, is it just a straight translation? If the hybrid is a fit, you just move straight onto the driver? And
Obviously it needs to be a little lighter than
yeah,
the hybrid.
yeah.
Obviously everything needs to go in series, right?
Yeah.
So your driver's
But that
lightest
hybrid
club.
profile fitting, you just move over to the driver. The guys,
Yeah, obviously there's differences in that. And,
Yeah.
and right now they got the baseline on the driver, and
Right.
maybe they'll come out with one that goes lower and one goes higher at some point.
Yeah.
We don't know that yet.
Right.
So far the results have been fantastic. The tour guys love it. This is basically the KBS Tour Driver shaft. Maybe there's a C-Taper Light driver shaft or a lower launching one or whatever higher coming, but we don't know that yet. As we get more research and data, we'll know more and figure out where to go.
One of the great things about working out of Mark's shop in Scottsdale is the amount of the exposure that we have to better players. And what I've been able to do with Mark
Variety,
is
too.
it's not necessarily just the better players. For the past 20 years, he has all the fittings for the past 20 years. So we have all of that information to pull from. In trying to come up with what is the best stiffness for a 50-gram shaft. It eliminated a lot of our guesswork. We're pretty good about making an educated guess, but what this did was confirm, and also we learned some things, but it confirmed a lot of what we expected. But it's really reassuring to me to be able to look at. I like to analyze data, and to have the amount of data that I have at my disposal because of the amount of work that Mark's done over the past 30 years is a huge benefit. There's nobody that has more information than I do in order to do my job, at least not in this industry.
Yeah, we don't know exactly what shafts are right at some point, but if you start in the middle and then you figure out what are we missing, you can kind of go in the direction that the majority of the people need. So like with the graphite, the max graphite, we need one that goes higher. What happens with the driver shaft, we don't know yet, but we will continue to develop that, and the more test subjects we got, whether they're tour players, and we have 158 tour players in the database, and we see them every day, 2 or 3 of them, to it's a 5 handicap lady like Sue that played in the U.S. Senior ladies amateur stuff, who only swings at 80 miles an hour. But there's a whole range of people, and as fitters, as all of us, we need to fit all these people, and whether they're 30 handicaps or +8s, TK robot, I see. All those things need to be fit. So, basically, you look at the middle of the window, what the most people need, which is where you start with, and then you see where are we missing it. We need to go right or left, higher or lower, left spin, more spin, and continue to develop things that round out the spectrum so we can fit everybody.
Yeah, I look at this whole fitting thing, and everything that we've done at Cape. There's nobody that believes in fitting more than I do. Mark maybe equal, but there's absolutely nobody that believes in fitting.
Carson Solheim, I'll give him some credit.
I don't believe there's many people out there that believe in it the way I do, but I look at it as almost like a painting, and I want to have everything. I want to have it full. I want to have a shaft that's going to fit every single person out there as best we could possibly do it. And I would say now we're finally at a point where our canvas is getting really full. On the iron side, we're there. You know, because in the lower weights, with steel, you're unable to maintain the efficiency. There's only so much you could do with steel at these very, very low weights. So when we brought the graphite in, that allowed us to go after an entirely new group of, you know, a new part of the golfing public as far as being able to fit them. But again, you know, this is about fitting. The TD driver shaft is it's all about fitting, and you know, again, I just can't tell you how much when my dad invented frequency matching back in the late 70s, and we really started to understand what we were doing, I didn't even know I was fitting. I had no idea, you know, what we were, you know, fitting was not something, it really wasn't on the map yet.
Nope.
And, you know, we had the players going around, oh, I'm a 7.3, I'm a 7.5, I'm a 7.7. Back then, people played stiffer shafts than they do today on average. Shafts were heavier. And for whatever reason, with the ball and what have you, back then people did play a bit stiffer shafts than what they do today on average.
Speaking about putting fitting on the map, I would say you put fitting on the map.
You gonna blame me for that one?
Yeah. So you went from a shop in Connecticut.
I had a shop in Connecticut up in 1990. I think I met him like 1992. He went up, and
Yeah.
I was the first, you know, training guy on the frequency stuff, which is all complicated with a lot of people. I'm kind of good with math, so I kind of got it. Guy John Gill that worked for you explained it very well, and we got all that stuff. I need to speak for a second on frequency, and there was some misunderstanding of what frequency means and how it works, right? Just a little bit. So we actually have machines that measure EI curves, 3,000 points, and all that stuff.
And you had an
it's-
EI machine.
yeah.
You were the first one to build an independent EI machine.
Yeah, we built one back like 20 years ago, which Mizuno
Right.
still uses in their R&D.
Yeah,
And
and I
then we
read
built a
a
newer
Golf
one.
Digest article about it, and
So
then
we built a
built
newer
one
one that
myself.
does it on
yeah.
a cantilever thing.
Yeah,
It's
yeah.
way more accurate. It measures almost 100,000 pieces of data in 2 minutes, which is available to you guys if you ever want to know what every shaft does. But everyone seems to think frequency doesn't mean anything. That's not entirely true. If you look at EI curves and stuff, they're directly correlated with frequency. So now, does the shaft bend more at the bottom? Does that feel softer? Yes. Does the shaft bend more at the top? Does it feel stiffer? Yes. Is the overall frequency of it how much load that puts on it? Absolutely. I mean, it's a direct correlation. So although if you look at our fitting software and stuff, how we do things, you know, it might tell me, okay, you need a 6.0 frequency on the old FM scale at this driver, but you might need a 7.0 in this one because of torque and kick points and other things. But the consistency in frequency as far as a building process is very useful, and that really hasn't changed. His father's vision of that was absolutely correct. There are other things go on. There's torque and there's weight and there's, you know, kick points and other things that affect that. But overall, as a universal like figure, it's pretty good. Now, obviously, apples aren't to apples, right? So a 5-inch clamp, a 2-inch clamp, it gives you different numbers. But relative to each other, it does actually mean something. We use it as a way of, you know, counteracting and building things to specific flexes. Now, they may be different specific flexes based on the properties of the shaft, but, you know, it's more important than people think. So people that say frequency doesn't mean anything anymore, yes and no. I mean, given the other relative information that you have from what the shaft does, it does mean something. You just need to keep the other things in mind. So his father had a really good invention on that, and it's proven out in math and in science that it really is, a really good measure of how stiff a shaft is.
Where do you see the future of independent fitting now that the term fitting has been taken over by the big box stores?
Well, it's a bit of an issue, right? So fitting is an interesting thing. So I went and got fitted. Well, where'd you get fitted? I went to PJ Superstore or whatever, not to bash them by any means. 20 minutes, the guy told me I need this shaft. Okay. You come to a place like ours, which is the other end of the spectrum, and it's an hour and a half, and we measure all kinds of stuff. That's a different fitting. There are different levels of fitting. Now, does everybody need the most top level? Maybe, maybe not. I would argue that a big misconception in the industry is a 30 handicap doesn't need a fitting and a tour player does. I would say it's the opposite.
Yeah.
Give me a 30 handicap and I drop him 10 shots.
Exactly.
Give me a tour player, I'm trying to save him a quarter shot a round.
Right.
So the worse players there are, the bigger the benefit.
The tour player is to some degree self-fit.
Yeah,
Because
well, they
he
can
can.
find the middle of the
Because he can.
club.
Yep.
They're good at it,
Yeah.
right?
Yeah.
So
Yeah.
so it's bad guys or not.
The bad guy needs it the worst.
Technology
Well,
helps the
he
higher
needs it more.
handicap more.
Yeah.
Yeah, like Mark
So-
said, the 20 handicapper is going to have a lot more to gain from fitting than a 5 handicapper.
And
Yeah.
that's a big thing in the industry we need to dismiss, right? So, I'm a 20 handicap, I don't need a fitting. That's absolutely incorrect. It's the other way around. And let me see, I see 2 or 3 tour players a day, if not more, and we're trying to shave quarter shots. Give me a 20 handicap. That's like bread and butter. Like, okay, let's see what we can do. You shoot 95, we shoot 85. It's much easier. And the technology helps those guys that don't hit in the middle way more than it does the tour player hits in the middle of a golf club all the time.
Yep.
Obviously, a tour player is obviously going to make more money making 2 more shots around a tournament is, hundreds
And
of
the
thousands of
recreational
dollars,
golfer
right?
who's betting quarters,
Yeah,
right?
exactly.
Yeah.
Betting quarters, it's a whole different deal. But, it seems like the industry now has changed. I mean, a few years ago, I think it was 2 or 3 years ago I was here, and I had one of the OEMs say, I'm going to sell you components, and I almost fell out of my chair. And I'm like, I didn't think this would ever happen.
Yeah.
So the OEMs now are realizing, because the incremental differences in golf clubs from one year to the next is getting smaller and smaller. Obviously, you're up against the USGA rules, the RNA rules, and the other ones that are really hard to break is the laws of physics, right? So the differences in golf clubs every year are getting smaller and smaller. And at some point, we hit this plateau where you can't.
So we don't have Moore's law in golf.
No, but the
We have the
advantage
inverse of
is,
Moore's law. Yeah,
the
yeah.
people change, right? So
Yeah.
I swing 100 miles an hour now, and 5 years ago I swung 110. So the clubs I had 10 years ago don't
They
work
don't
for
work
me anymore.
Yeah.
So the good news is we still need a fit to optimize each player's clubs. So even if technology doesn't advance over time, we still need new clubs, which is great for all of us, right? And that's Kim's philosophy too, to have a whole line of things, whether it's graphite shafted irons that go from 50 grams to 110. The ones you're playing now are probably not the ones you need 5 years from now. So that's good news for the industry, and I think the OEMs and all the shaft companies realize the future in selling clubs is not a technology jump. It's, fitting better. I can get a guy that's got a club that's 10 years old. Does a new club any hotter? Yeah, maybe not. If I get the right launch and spin, can I get him 20 yards? Probably.
Yeah.
Where we go from that, whether it's a higher launching version or a lower launching version, we don't know quite yet.
Yeah.
But there will be different iterations. As Kim explains, he wants to fill the canvas up. So everybody that gets fitted has a spot somewhere. You kind of do the 80-20 rule to begin with, so you make the blue board stuff that's in the center. This is what we need. This is most of the people. As you kind of mess with that a bit, you figure out, what do we need? Higher launching, lower launching, other stuff, more torque, less torque, to fill the rest of the canvas up, essentially.
Okay.
Right?
Okay, I think it was something about this. We've come out with a couple new products this year. We've come out with a putter. It's a rapid step. It has a very, very stable top to it. I have never ever have copied anything. But this.
Who'd you copy?
That there was a shaft out that I saw that was it's a putter shaft that is extremely stable. and it happens to be extremely stiff as well, and that's kind of how they got the stability out of it. It has a graphite top, there's an aluminum insert, and then you put the steel shaft through the bottom of it. And I'm looking at this thing, and I'm like, geez, I could make this out of steel. This is going to be easy. And I kind of copied what I was looking at. And so that's one of the shafts that we're coming out this year. It's called the One Step. Mark's doing some testing right now.
What's really cool about that is, right, so it's one putter shaft. It's all steel. It's skinny on the bottom. It gets bigger. It goes up. So essentially, the more you chip it, you can make a stiffer putter shaft or a weaker putter shaft, depending on the head weight, what kind of feel people like. So you got one shaft that can do a whole bunch of different things. It's kind of like the old rifle blanks where you started, you had blanks.
Yeah.
And you could trim them down and cut the butt off and make them really stiff and high kick. Right?
Yep.
Or you could leave the tip all together and cut the butt down and make it soft and make it launch high. Same kind of thing with putter shafts. Now, the nice thing about it is there's some other putter shafts being developed out there with graphite and steel and other things, but they get expensive, right? So you've got carbon fiber mixed with steel. As everyone says with putter heads to some extent, everyone wants a milled block of steel, so it's one piece. Well, we agree with that in putters. It feels more solid, right? So the neck is all one piece, the whole thing. Same thing with a putter shaft. You got multiple pieces put together and glued together. The feel is not going to be as good as a solid piece to some extent. And the nice thing about this putter shaft is, you can trim it and make it stiffer and lighter, or based on the head weight and the guy's feel. So it's got a variety of things, and because it's all steel, it's not crazy expensive. I don't know about any of you guys, but I've had a difficult time selling $200-300 putter shafts. It just doesn't seem to happen. But putter shafts in general, I think, have been kind of thrown under the bus. It's hard to sell them, but if they're not that expensive and they feel better and they work better, for $30-40 or whatever to change a putter shaft, I mean, we're spending $40 on grips now for putters. Super Stroke's a great example, probably 90% of the market, and they're great. And they got back weights in them. You can adjust them. Why not with shafts? But using graphite and other things in putters has never seemed to fly for some reason. And I don't know why that is. Maybe it's a price point. I don't know exactly why. But changing feel and stuff. I mean, I've made long putters.
Yeah, with this shaft, we've done some stuff. Mark plays with a long putter. And because of what we're able to do with the tip section of this thing, this goes from 580 to 370 in about 1 1/8 inches. So it's a really rapid step. And the whole idea was to make this thing as stable as we could possibly make it. In this case, the stability is stiffness. In not all cases, people think that in order for something to be stable, it has to be stiff. That's not correct. But in this case, it is. So what we found was with this thing, we were able to do, when you put a 450, what is yours?
Yeah, 450 is the head weight.
His head weight is 450 grams. So
heavy.
we have a long parallel length on this shaft at the bottom, the 370 section. So he's able to take it, trim about 4 inches off the tip.
Or even more, yeah.
Or maybe a tad more. And anyway, I got a tad more thing. And so...
Tad ahead up on there.
Yeah. Tad just came into our booth with this shaft. And
he's got hickory stuck in the top of the thing, believe it or not.
He's got, it's a hickory shaft, and with the One Step in the bottom of it. But anyway, what I was trying to get at, by trimming that shaft for the long putters, for the really heavy heads, it still feels really good, but you have the stability of it. Mark alluded to, putter shafts have pretty much been an afterthought. I didn't realize until about 2 years ago, in working with Quintex machine, is probably something some of y'all are familiar with, but the amount of displacement at impact on a 15-foot putt just blew me away. I had no idea that there was that much displacement.
What's going on?
And
well, Kim, if you could explain, which I think would be a good thing for people to understand too. Obviously, graphite's different because there's different materials. You can put different, torques and stuff like that. But in steel, there's basically only two ways you change flex. One is wall thickness, and one is diameter.
That's right.
And diameter is what, 3 or 4 times
It's
the
the
effect.
power of 4, so it's
Power
about
of 4,
12
right?
times. Yeah.
Yeah, so yeah.
It's a much more.
So the diameter of a steel shaft is way more important than the wall thickness.
Yes.
And that's the only 2 ways you change flex or frequency or whatever you want to call it.
Yeah. The thing about
so-
the thing about steel is it's an isotropic material. It has equal strength in all directions. Graphite only has strength in the direction that the fiber is located. So in graphite shafts, we obtain stiffness, and I'm sure a lot of you guys know this, but I'm going to go ahead and tell you anyway. The stiffness comes from the 0 degrees axis, the fibers that are going straight down the shaft. That is the one that supplies stiffness. Now you can have just nothing but 0 degrees, and that thing is going to be stiffer than you can imagine, but it's also going to, you can just take it in your hands and twist it like this, because there's nothing to protect, or there's nothing to eliminate the torsional value. So, and I'm sure that a lot of y'all know this. So you put the 45-degree angles down in order to eliminate torsional, the torsional value, and which, you know, so there's things that we can do. That's why we're able to take a 50-gram shaft and make it stable, because of you know, the way the graphite material.
If you try to do that with steel, it's going to break. It's
Well,
so thin
you
and durable. It's just
can't get
do
there.
it.
Can't get there.
Yeah.
But this is a putter shaft. There's no reason to make this thing 80 grams or whatever. I mean, it doesn't. Putter shafts tend to work best when they're a little bit on the heavier side.
130-ish, yeah.
And again, it's a homogeneous material. So when I saw this thing with the graphite and the thing and then this and it's glued together, and I'm like thinking to myself, well, geez, you know, you got 3 completely different materials there, not to mention what you're using to bond this thing together. And in order for it to feel the way, you know, to feel smooth and to feel the way that I would think that it should, I don't know how you get there from there. I just have no idea how you could possibly get there. But anyway, with this, like Mark was talking about, the reduction or the importance of the OD. With what we do with that putter shaft, it's really it is amazing. In fact, that we've eliminated the movement at even a 15-foot putt. And at the same time, we've got it so that it feels good.
When do you think we might see it?
It's available now.
Yeah, it's available now, and you're going to see it in some OEMs, I think, pretty quick. It's a pretty cool gadget.
Yeah,
Not super expensive, really good, and really versatile as far as, you know, how much you want to tip it, make it stiffer, weaker. Like I said, you know, I use a long putter, so I tip the, you know, almost to the end, and it's really stiff because it's wide diameter.
Now,
But you can do the opposite too.
It
You
does
make
require to
feel
put if you're doing a long putter,
better. Yeah, you need a
you have to put an extension in it.
But yeah, but the concept's there. From what used to be standard in most putters was 330 gram heads. Now it's 350, 360. So they're getting heavier. So you need a stiffer shaft to do that. And if you think about the bottom of the shaft, you know, and even just driver, fairway, whatever, that's the feel part, right? So the bottom, if you make the bottom a little softer, it feels better. Regardless of the overall flex or the frequency of the whole thing, you know, the tip is what you feel. So it has a huge impact on feel and performance, and that makes it really versatile and not as crazy expensive as gluing a bunch of pieces together.
Okay.
This is okay. These are frequency numbers up there. They're category 1. I don't like RS and X. I don't think any of y'all do either. The only reason why we have to put RS and X on golf shafts, and I've tried to get away from it, is the OEMs demand it. They don't want to have to educate somebody what a category 2 is. They want it to be an R flex. So anyway, this shaft is designed and targeted solely for the aftermarket. This is your shaft, and
I remember from the measurements that the category 3 didn't matter what the weight was.
they're all the
The
same.
category
Right.
3
No,
was
that's
about
good.
the same stiffness,
Yeah.
and the category 4 was the same.
Yeah.
I mean, you
Well,
didn't make category 5s at What was the latest weight? 50 grams?
No, 60
40.
grams. So we're going to have to do it. Now, that's
Yeah.
one of the things that's happened.
That's hard to do, though.
We've
Try to
had-
make
yeah,
things really
yeah,
light and really stiff.
I get it,
Hard
yeah.
to do.
Well,
I
that,
absolutely
but,
get
but we'll do it. We'll do it. We're going to have, eventually, we're going to have a 50 gram in the X Flex, only because we've.
It's
I
not
did-
an
I-
X-Flex.
Well,
It's category 4 or
it's
category
category
Well, you
4.
can do it.
Category
Yeah.
4.
It's expensive, but you can do it.
But
Oh, yeah.
so there are some things that we've learned that we're going to have to do in order to expand this thing. But I wanted to keep it as compact as possible. I didn't want to have to, you know, you have to have 30 shafts in order to do this. But with those 15 shafts right there, you're going to be able to fit 9 out of 10 people that walk in your shop easily. And you know, again, it's the backbone of what we're going to do. This is our benchmark. And like I said, we're very, very excited about it. Some of the things that, if anybody goes on Instagram, look at what Phil did last Friday. It's called Bombs, and it was something that he did on his own. He wasn't, you know, no, we didn't ask him to do it, but it's a real nice piece in my, you know, in my estimation, because it really paints our shaft in a wonderful light. But what it was him and a bunch of buddies at Madison Club. He was hitting drivers, and there's a launch monitor set up there, and his numbers were at 121 miles an hour swing speed. He had 180 mile an hour ball speed. Now, if you know, I'm pretty sure y'all that have worked with
1.5-ish.
Yeah, yeah.
Yeah.
I mean,
all you got.
I mean, there's nothing you can do to get ball speed at 121 miles an hour. For him to get 180 ball speed, he had to have hit that thing
In theory, that's dead center.
it just, you couldn't, you can't get that much out of there almost. So again, that speaks to the efficiency of the shaft. It also speaks to the fact that he hit it in the middle of the club. But again, I just can't tell you how excited we are about this product. I've never had anything that has exceeded my expectations as much as this one has.
Great. Thank you.
Thanks, Russ.
Okay.
All right, Russ.
Mark?
Good to see you.
Nice to see you.